Hey everybody, and thanks for joining another one of our InfluxDays sessions. Today we're going to be talking about industrial IoT and how our products fit and the ways we're seeing customers use them. My name is Brian Gilmore, and I'm Director of IoT and Emerging Technology at InfluxData. I love working with our customers and helping them connect up all these industrial IoT systems to our databases in the cloud and at the edge. So we're going to talk about a few things here today. First is really what the challenge is in terms of modernizing industrial operations, especially when it comes to adopting new technology and new software. I also want to talk a little bit about what we're seeing as sort of the start of a diminishing relevance when it comes to those legacy solutions like industrial process historians. And finally, how can you bring it all together and use a modern technology stack to monitor, optimize, and predict industrial operations and maintenance? So first, just to define and level set on industrial IoT, what we're talking about here is all of the technology that sort of glues together the industrial applications, robotics, smart sensors, and any software-defined production process. There's several challenges here that are leading to this sort of investment in digitization. Number one is local awareness. People have access to the HMIs and to the SCADA systems, but they don't always have advanced or any type of informative analytics involved in those SCADA systems. So they might be exporting data to Excel or just printing it out and taking a look at it. And this really isn't giving them the opportunity that they need to really optimize things. The second piece that they struggle with is remote visibility. Now, a little bit of this is about, some security concerns in that they don't want anybody coming in and, stealing their IP or changing set points on the machines. But it's very easy today to use technology like InfluxDB and agents and like Telegraph to actually connect these plant floors up to a cloud service in a way that gives read-only access to your data and does so in a very secure way. I think if you look at the domain expertise piece too, there's really a challenge when we have retiring operators who have spent a lot of time over the last several decades learning the ins and outs of the operations, the equipment, the assets, and the processes. And it's really difficult to actually encode that domain expertise into something that's consumable by this sort of new set of operators who are coming in as they graduate high school, trade school, and college. So I don't want to sort of point fingers, but I think it's important that we take a look at, what is the relevance today of this sort of old school legacy industrial process historian? Now, there are good things about these applications. They are truly real time. They are well integrated with the existing systems that are on the plant floor, the ICS systems, SCADA if they're still being used. And to the operators, they're very familiar. And because they're familiar, they feel comfortable and they feel at home. I think when we talk to customers, though, about why they're looking to replace these systems, the first thing we always hear is cost. There is no free trial, there is no open source version, there is no roll your own, and there's very little offered in terms of cloud services that are cost effective for these companies. The other thing is that these systems tend to be extremely complex, largely because they were designed 20 or 30 years ago for people who were technicians and experts in the types of applications and solutions. The other thing is that they're not really designed to be interoperable. And when you have siloed systems and siloed data, where it's sort of like bad news to try to connect it up to other systems, you will oftentimes have problems in making the data that's stored in those silos valuable to a broad set of users across your organization. Now, finally, for the ugly. It's really hard to integrate OT systems with IT world and with the cloud. And this isn't always a technology problem. We can look at it from both a people problem, a process problem, and then finally a technology problem. On the people problem side, it's typically around misunderstanding of best security practices and what it really means to connect your plant floor to the cloud. I think there's also a problem with slow innovation in these systems. If you look at the sort of rapid innovation that's happened in more modern cloud-based and on-premises applications related to digitization of the plant floor, they are coming out with new capabilities, new features, new integrations with tools and, features like machine learning and artificial intelligence that bring brand new capability to the operator working the plant floor who may be using a wrench 50% of the time and their software 50% of the time. And then finally, I believe they put unnecessary limits on the capabilities and the opportunities for people on the plant floor to really do things like experiment, innovate, use their creativity, and basically collaborate with each other, with other factories, with other systems in their IT and OT environments. Now, calling that out it's not for the purpose of pointing fingers, but I think we all can make an impact together to make this world better and to make this digitization experience of industrial IoT faster, cheaper, and better. And I think the first thing we should do is we really should start looking at building and providing the tools that allow the experimentation and the innovation. In OT world, you are always worried about keeping the system up. Availability is number one, even more so than security in a lot of situations. That oftentimes provides an environment, whether real or not, where people don't feel like they can do tests, they can check things out, they can do that experimentation, where maybe they have come up with a way to do things better, but they're too afraid to try. So we can do some work there to actually enable them with tools that apply more to a typical DevOps world, where they have test systems, dev systems, and then production systems where things can be rolled. That's not going to happen with a lot of these legacy software systems. The other thing is observability. So if you're rolling out all of this technology, none of those legacy systems are designed to receive data from the multitude of systems, whether they are IT systems, servers, applications, network switches. They're good at the stuff from the PLCs and the RTUs, but getting that all together into one system is extremely difficult. Now, I spent a lot of time on the plant floor in my prior career, and one thing I knew was when we would have a process problem, it was oftentimes caused by a sensor. That sensor may have flatlined. Now, to figure out why that sensor flatlined would require an electrical meter to check the continuity. It would require a network testing tool to understand the network connection. It would require a login to the switch to understand if it was something that had been configured in the switch or the router. And then I would have to take a look at all of the services that were running on the SCADA servers. And sometimes I would get all the way to the end and still not know what was going on. Having a complete observability view of all of the data from the IT systems that glue together the OT systems, as well as those technical industrial OT technologies, whether they be PLCs or RTUs, is going to be key to really digitize these plants and let the operators who run them become much more effective in their jobs. I think another key point we need to look at is who the next generation of operators is going to be. We all know, if you've got kids or any kind of exposure to younger people, that these are digital natives, right? They grew up with an iPhone in their hand, they understand technology, and they have high expectations for usability and access, and they have no patience for obstacles when it comes to technology. And I think the more and more we can build into what their expectations are, the better our platforms will be for the future of industrial. We also need to take a look at any opportunities we have to integrate OT and other legacy technologies with emerging technologies like machine learning, artificial intelligence, augmented reality. I mean, there's opportunities everywhere. And these technologies, while they may seem to be more hype than reality today, they're being developed for a reason. And the reason that they're being developed is because the future versions of those platforms will apply new capabilities around access, security, and all of that. So really, all of this together is what we talk about as the future of industrial operations. And I would love to have any of you who are interested in this join us on this journey. So all these challenges we just discussed require that we take a little bit of a different approach to industrial IoT, whether it's from here on out or tomorrow. I think the best thing we can do is think about these challenges from a user perspective. So what are the things that keep your operators up at night? What is the last time your plant manager had to go in the middle of the night to solve a problem? And if you can figure out how to use technology to instrument the assets and the processes to deliver to those people the insights they need before things get bad, you'll create a proactive environment where your operators are saving time through those types of efficiencies. The way they can do this is they can write their own apps or connect up their other apps to the REST APIs. They can use client libraries to build these apps out themselves if they so choose, But we also provide in the application itself a good set of tools, including a data explorer, which will feel very familiar to somebody who's worked with a historian front end, and notebook interfaces that your data analysts and data scientists will love, as well as a set of visualizations where you can just build your own dashboards right within InfluxDB. Now, the other thing we've done is with that sort of top-level application building environment, we've spread out the capabilities of the database to a more edge data center and cloud model. Whereas we used to just say we have one database, run it where you want. We now look at OSS, open source, enterprise, which is our data center product, and InfluxDB Cloud as really one stack, a vertical stack where you can capture and store data where it's born, and then strategically and intelligently move it to where it needs to be consumed. And at the edge, you can do this with Telegraph, or you can even install InfluxDB on very small footprints. There are companies out there who are putting it in their RTUs, and we have partners like Opto22 and Rockwell who are making the product available to their customers through some of the container programs that they're delivering through their advanced industrial IoT platforms. Getting this through to OSS gives you a place to store it, stage it at the edge. But then, knowing that cloud is a bit of a dirty word sometimes in the industrial IoT space, we really need to push home the point that all of these applications will eventually move to the cloud. There's just so many conveniences in cloud. There's so many cost reductions. There's so much more monitoring and capability when it comes to the availability and the cybersecurity of those applications that eventually the OT teams will catch on and believe in cloud as much as the rest of us do. But those cloud data sources, whether they're coming in from data sources connected to Kafka or to MQTT brokers, stuff you're grabbing off of, pub/sub models for your cloud service provider, whether you're using our cloud native application or our cloud native features to integrate with your MQTT brokers, or just pulling data directly from the applications that you're already running in the cloud through our Telegraph agent or through our Flux SQL connector. Ultimately, what you have now is a place where you can collect and store any data anywhere and then strategically move it around in a way that makes your analytics, your data science, and your troubleshooting much, much easier and much better. So how could you get there with InfluxDB alone? You may have heard that we're on a vacuum in one of our previous talks, but we can't operate in a vacuum. There are lots of other applications that already work on the plant floors that are valuable sources of data for InfluxDB. So if we think about your SCADA systems, your industrial control systems, of course, capturing the sensor readings that are attached to the PLCs are really important. But you can't forget things like your manufacturing execution systems, your ERP systems, your asset management systems, and your maintenance management systems. All of those include as much important and valuable information. While it might be less real time, it still paints a picture about your assets, your operations, and your processes. Now, those devices and infrastructure you can also connect directly to. Whether it's your PLCs or it's your human-machine interfaces, or a lot of times we're seeing with modern robotics, these are talking more IT-like than they are OT-like. And you can use Telegraph and other capabilities within the InfluxDB ecosystem to communicate directly with those robots to get the values that they're using to do the processes that they're running. And then you can also understand a lot of times a little bit about things like the actual core OT or IT that glues it all together in those robots, so that you can know, is your production problem related to the actuator, or is your production problem related to something that's running on the server as a service or a file or whatever. Getting data through to InfluxDB, of course, we've talked a lot about Telegraph here. It's very powerful, and there are a number of highly relevant OT and industrial IoT integrations, including the MQTT consumer, the OPC UA consumer, which is getting ready to support OPC UA events. We have a Modbus plugin, of course, HTTP, which can talk to a lot of those other applications and services that aren't related to your SCADA system. And even if you have other services out there that are staging information about your supply chain or your customers, you can integrate with the Kinesis and the event hubs of Azure to really pull that information in and just provide a sort of unique enrichment and perspective on it. We have a lot of sort of new developers working in these OT spaces. We work with a number of the modern historian platforms. We work with a number of the modern HMI platforms. And we're working with a lot of the companies that are developing and delivering new industrial IoT platforms like Bosch and their Control-X platform, Rockwell and their industrial IoT gateway platform. And all of these allow you to either deploy or install both Telegraph and InfluxDB within that container ecosystem so that you're natively using InfluxDB within your Rockwell or within your Bosch system. Finally, we have a bunch of partner solutions, which are all really powerful and really well developed. Most of you, if you're in this business, are familiar with Kepware. It's like the leading sort of driver and protocol conversion software middleware out there. You've got companies like Highbyte who are coming up fast on Kepware's tail, doing the same thing, but with a little bit more modern in terms of microservices based and some of the tools they use in there. And then, of course, we've got our partners at PTC ThingWorx who lead in the sort of like connected product and connected manufacturing solutions. And then, of course, Control-X, like I just mentioned, as well as WinCCOA. All of them have native supported integrations with InfluxDB. So it may not be as hard as you would imagine to get data from those systems to InfluxDB. Now, once you have that data in InfluxDB, you get to take advantage of the core engine. You can collect, of course, we've just talked about everything on that left side, but transforming and aggregating and downsampling, triggering, running scripts, all of that can be automated in a way in InfluxDB that probably will feel a lot like the automation you're running elsewhere on your plant floor. And we're starting to see some customers even connect the automation in InfluxDB up to their automation systems in a supervisory manner, where InfluxDB may be making recommendations about set points or other sort of data set points to limit costs or reduce risk or improve supply chain flow or whatever it might be. So you really should explore all of the capabilities there and see how it could fit into your operations. Now, if we're talking about sort of the front end and the way people are going to run dashboards and build reports, we're oftentimes seeing people use InfluxDB in the industrial space for basic monitoring and diagnostics. So when an asset breaks down, you have all that history of information right there in InfluxDB. It's easy to access, easy to research, easy to visually detect anomalies and find the root cause of your problems. But you can go a little bit past that as you start to integrate with our partners and libraries that allow you to integrate with machine learning and other artificial intelligence platforms, where you can really start to do advanced failure detection, sort of unsupervised. No human needs to see the spike. The system can see the spike itself. And we're even starting to see a lot of proactive, predictive maintenance and even recommended sort of maintenance program where the data is actually driving the industrial maintenance and operations. Another thing you can do is use all of that data, give it to your data scientists, give it to your analysts, and let them use that data to optimize your processes, optimize your resources, give your customers and client visibilities, and actually a lot of companies are starting to use time series data to serve new solutions and create new lines of business where they can actually make money off of the data from either customer assets or their own assets. And this is what we see a lot with power companies and smart meters or connected car companies. It's a really exciting opportunity. So if I'm trying to think about, with the tiny bit of condemning we did in the very beginning with sort of the old way, I had to think about if there was a possibility of creating a brand new and simple industrial IoT stack that could provide the opportunities that we've sort of outlined in this presentation. And I finally think that the answer is yes. So if you think about those three main data sources that you would want to collect, sort of your industrial controls data, any data from your robotics, and then your digital factory systems, which would include your MES, your EAM, your CMMS, all those systems. With our partner companies who provide that middleware to integrate with it, as well as our Telegraph agent, we now are basically unlimited in the ways that we can capture and collect that data in near real time. And now that we've sort of taken that layer of the InfluxDB database and made it much friendlier to sort of a distributed edge data center and cloud environment, we can let the industrial operators and the people running that technology keep the data where it's born, move it strategically to where it needs to be consumed, and otherwise turn what might be a very expensive trip to cloud into a very effective, highly distributed time series database for their industrial data. Now, on the top end, we've started building the relationships with the companies that these operators know and love in terms of the modern interfaces. So companies like Clarify, who you'll see in Jay's demo, a really cool interface that allows you to explore data in InfluxDB in a way that operators on the plant floor who are familiar with the front ends of many process historians will be extremely comfortable with. You may already be using Seek on top of your legacy historian and may say, well, I'd love to run it on top of the data I have in InfluxDB. You can do that as well now. They've got support for 1.x today, and they're actively working on supporting 2.x, which will bring the Seek user interface to InfluxDB Cloud. And finally, I talked a little bit about Factory, which is another industrial process historian. So they have taken the InfluxDB basics and they have wrapped it in all kinds of tools that make it feel like a native and legacy process historian, but without any of the bad side and all of the good stuff. And if you want to work with a company who's got the services and the understanding and the experience on what an industrial historian based on InfluxDB would look like, you might want to start there. And we're actively working with Factory to make sure that things that we build in the future will interact and will support the customers that they've already delivered the Factory platform to. So now that we've sort of shown you that this stack exists, the big question is, what will you be able to do if you start to deploy it? I'm really excited to see what you build when it comes to improving efficiency, reducing costs, optimizing your workforce, building new lines of profitable business, or even optimizing your supply chain. And we hope that InfluxDB can be the foundation that you build this all on. So thank you very much, and I highly encourage that you take a look at Jay's demo of using industrial IoT and analyzing in real time. It's going to be a great follow-up to this session, and thanks again for your time.